Hello, in this video, we'll be creating gears through Autodesk Fusion 360. This video is provided by AlphaGenesis 6436. I hope you enjoy the video. Gears are the fundamental components in machinery. They are used for transmitting rotational motion along different parts of a machine. Depending on the gear ratio and its type, the gear could change the speed, force, or direction of a moving component. Gears can exchange the torque, which is the amount of turning power it had for speed. Gears that provide more torque generally take longer to rotate compared to gears with less torque. The size difference between two gears determine the ratio. The bigger gear has more torque and rotates slower, while the smaller gear spins faster with less torque. Gears take different forms and shapes. This is how gears can change the direction of the transmitted power. This is an example of gear ratio because there are two gears of different sizes. The small gear on the right has less teeth or points than the large gear on the left, so for every revolution the large gear makes, the small gear will have to spin more. Now I'll be teaching you guys how to make the Spur gear. To start off, we'll go to the Tools tab, and you'll see an Add-in icon. Press that, and then you'll have two tabs. We'll go to the Add-ins tab and scroll down. You'll see two types of Spur gears. One is programmed in JavaScript, and one is programmed in CC+. It doesn't matter which one you choose, but for now, I'll be using the JavaScript one. When you select it, go to Run, and you should find it in our Create tab. It's the bottom one, Spur gear. Okay, so now we'll be inputting different values to create our custom gear. To start off, we have the standard, which is the metric or English. I'll be using metric because it is universally understood. For the pressure angle, I'll be using 20 degrees. The pressure angle is one of the main factors to define gear teeth. It is the angle between the common normal at the point of the tooth contact and the common tangent to the pitch circle. It is also the angle between the line of action and the common tangent. I would keep it at 20 degrees unless you really understand how to create gears. Next is the gear module. The gear module is the unit of size or ratio of the gear's pitch diameter divided by the number of teeth. The module is only available when the standard is set to metric. I'll be setting the gear module to 2 because I want the overall pitch circle of the gear to be smaller. The pitch diameter on the bottom indicates the pitch circle. It is not the outer diameter of the gear, but rather the circle in the diagram shown above. Now we'll be moving on to the number of teeth. The number of teeth option allows you to define how many teeth are placed around the gear. For our case, I'll be setting the number of teeth to 15, so I can easily create a gear ratio of 2 to 1. Now moving on to backlash. This backlash option allows you to create a clearance between the teeth. This clearance prevents tooth damage and overheating from wear. It also provides space for lubrication. I would set this value to 0.15 millimeters to have a 0.3 millimeter clearance between both gears. Because we are 3D printing these gears, we need to have a backlash to allow the gears to rotate smoothly. Now moving on to root fillet radius. The root fillet radius is the small radius that connects the profile of a tooth to the root circle. There is a value limitation that cannot be exceeded, an undercut that prevents gear teeth from correctly meshing with each other, will result if it exceeds the maximum value. I'll be setting the root fillet radius to 0.9 millimeters to ensure that our gear teeth are strong. The gear thickness is the extruded height of the gear. I will be setting the value to 5 millimeters. If you change your mind or want to use less material, you can always change the gear thickness with the Spur gear generator. The Spur gear generator will let you use the press-pull tool to change the thickness of your gear. Lastly, we have the hole diameter. The hole diameter is simply defined as the diameter of a hole set in the center of our gear. I recommend inputting 0 for the value to make it easier to create custom hole patterns. After inputting all the values for our features, you can look at the bottom to see the pitch diameter. This pitch diameter is a circle that is between the appendum and dependum of a gear. This pitch circle allows you to visualize the paths of the teeth, so we can easily put these gears together without overlapping the teeth. After we're done with that, we should press OK to generate our Spur gear. Now we will be using the Spur gear tool again to create the other gear. As you can see, all the previous applied values are still there. The only value that we need to change is the number of teeth to create the 2-to-1 gear ratio. I will be changing this value to 30. You guys don't have to follow and input the same values as me. You guys can input a different number. Just note that the value you input here will determine the gear ratio. Press OK and the new gear should be generated on the origin. To move the gear to the right place, use the Move tool. And input the amount of teeth on the small gear plus the amount of teeth on the larger gear for the x-axis distance. If the position of the gear is correct, but the teeth are overlapping, you can rotate the teeth different ways until the teeth are not overlapping. After we are done with the placement of the gear, we'll be sketching 2 circles in between both gears with a diameter of 5 millimeters. We will be doing this to create space for an axle. This axle will allow us to test our gears with an as-built joint. The axle that I'll be creating will be 4 millimeters in diameter. This axle will extend past the gears on both sides by 5 millimeters. After we are done with this, we'll be converting all the bodies into components. Turning them into components will then allow us to simulate the gears with an as-built joint. The as-built joint can be found in the Assemble tab, or you can search it up with the Quick Search tool. To use this tool, we'll be selecting the large gear first, then the axle. Make sure to switch the joint type to revolute. We will do the same for the small gear as well. After we're done with that, we will find the Motion Link tool in the Assemble tab. This Motion Link tool will allow us to synchronize the turning gears, and that will give us a better simulation. I will first select the joint that we created in the large gear. For the angle, we will be inputting 180 degrees. This is because we have a 2:1 ratio. This means that every time the small gear makes one revolution, the bigger gear will only turn 180 degrees. So for rotate 2, we will select the small gear, and we'll keep the angle at 360 degrees. After we're done with that, we'll select reverse. This will create an accurate simulation of how gears actually turn. Press OK, and now we need to ground the axles to prevent the gears from shifting when we are rotating the gears. And now we should be able to drag the gears and rotate them. If I zoom in to the gear teeth, you can see the backlash that we created. Now I'll be showing you guys a gear that I 3D printed and how it glides smoothly because of the backlash. After watching my video, if you guys are still interested in gears, you guys can look up gears on Thingiverse. Over here, you guys will see many gears of different sizes and shapes. These gears are all unconventional gears, and you can learn a lot from just looking at how these gears work. Thank you for watching this video. I hope you enjoyed it. Please check out our social media pages. And thank you for watching.